Hello and welcome once again to episode 49 of Code Completion. We are a group of iOS developers and educators hoping to share what we love most about development, Apple technology, and completing your code. My name is Dimitri and I'll be your host once again for this episode, and I'm joined today by my fellow completionist, Spencer.
Hey there.
So before we get into our main topic, it's time for our Indie App Spotlight. Today we are checking out Smart Filter by Jake Grant, an iPhone spam filter for SMS text messages. Spam Filter uses machine learning to check for spam messages and texts before they disturb you. You can customize its filters to always block or allow certain words, filter for links, or even security codes. And when spam does leak through, you can contribute it to the algorithm so it'll catch it next time. Spam Filter is completely free and supported completely by tips, so please be sure to download it today to support Jake, and don't forget to tip. And if you are an indie developer, we want to hear from you, so please be sure to reach out to us at Twitter at CodeCompletion via DM so we can spotlight your app in the future as well. So for our main topic today, we want to discuss all the new features that just made their way into Swift 5.5. Do you have any particular favorites, or should we just go down the list?
Yeah, no, we can just go down the list. Paul Hudson has made, or you probably already know it, but you all listening already know it, but it's what's new in Swift, and it's awesome. I mean, he does everything, but he's got this list of, you can say, I'm using Swift whatever, what are the differences between that and Swift, in this case 5.5, so we're just going from 5.4 to 5.5, but there are some great changes, so let's get into it.
That's what's new in Swift.com, if you don't know. And as Spencer mentioned, great resource, especially if you haven't been keeping super up to date with the Xcode versions, especially like when Xcode 15.1 or .2 rolls around. There's like a new version of Swift that also comes out, and that's a great resource to just like catch up and get an idea for what just got included that you might not be aware of.
Yeah, and it's cool because it includes like the Swift evolution number and links to the GitHub, what would you call that, like proposal for whatever this changes. So really cool.
Yeah, so you can read up on the whole process, which I try to keep up with, like every time. Like there are certain people you can follow on Twitter that will just like post when new proposals or even pitches like get brought up, and we'll talk about a few of them probably as we go through all this. But it's really a fascinating process to kind of watch the language evolve publicly, and not like hidden away in like mailing lists or anything like that.
Yeah, for sure.
So the first one we have on our little list that I threw together is that read-only properties can now throw. So if you've ever had a computed property and you've wanted to mark it as throwing, that is now possible, which is super convenient because they are essentially just little functions, but semantically they read differently. So now that async await, which we'll get to at the bottom of our list, since it's a big one, but now since that landed and they essentially needed the ability to mark properties as async, that is a new addition that they can now throw as well, which is super convenient and brings a little parity to the language and how it can be used, especially since they are essentially the same things, especially once it does get compiled down.
Mm-hmm. Yep.
Have you ever run into that before where you wanted to mark one as throws?
Not personally, no. So one thing that I do love, though, just kind of on that topic, is a lot of these things, especially like async await, which again we'll get to, I haven't even really experimented with. But one of the cool things about this what's new in Swift.com is it will give code examples of like, this is how we used to do it, and then this is kind of what it will be, or now what it is in Swift 5.5. So there's context there. It's not just like listing out what it is, but it's actually saying, here's how it works. Here, visualize the code and see what it's going to be. So that's cool. But no, I haven't personally needed that. It is a nice change, though.
Definitely. So what's the next one?
Yeah, so then we've got the pragma if for postfix member expressions. So the example that Paul Hudson gives is a great one, I think, in Swift UI, where you can say, you've just got like a text view that with like the string welcome, and then you can do pragma if OS is iOS, then you can have a modifier for font that's maybe a large title. Otherwise, it could be like a headline font. And what it will let you do is also nest those as well, so you can kind of do whatever you want. And he talks a little bit about, maybe not wanting to change kind of that whole view hierarchy between if and else and everything, but you could kind of get it. I think for me, it looks like SwiftUI is a huge thing with this, is just you can kind of optionally add these modifiers depending on whatever, for example, the OS, which, if we're trying to be cross-platform using, Catalyst or just allowing the Mac or the iPad apps to run on Mac, that's great. That would be something that can be useful to make it feel a little bit more, I suppose, natural. Just make things look a little bit better, perhaps, on different platforms. I don't know if you could do it with any other. Well, what he does, sorry to interject, he does it with, checking if the OS is iOS, or you can have like a debug flag, for example, to make some super vibrant color so you can see where views are or whatever. I don't know if you have any other examples of things that you could check for that might be useful.
So now, like, you wouldn't have been able to do this before, but now what you can do is combine this with the compiler check and the Swift version as well. So that way you can include code that would otherwise work fine in Xcode, and the newest version of Xcode, but it wouldn't be compilable on older versions of Xcode. So this is combined with like add available and stuff like that. A great way of making that possible. But my favorite use of this is specifically for cross-platform code, especially since SwiftUI has such a large API surface that is shared between platforms. Every now and then there are little things. Oh, the keyboard type not available on macOS because there's no virtual keyboard ever on screen. Right. And therefore it's just not declared in macOS, which is frustrating, especially when you just want to mark it as like an email, and otherwise the rest of the view is unchanged between platforms. That is something that will now be expressible using this new pound sign if directive, because you can just insert these modifiers little by little, depending on the platform that you're using, and that's going to be great. Up until now, you've had to kind of write your own modifier. For instance, on one project, my coworker and I, we made something called modify, and it just takes a closure and it passes the view that it's modifying. So it's like a super bare bones way of just getting the view that you need to make changes to, and then in there you could then do the pound if directive. But since you no longer need to do that kind of screwy code that really added a lot of indents every single time we wanted to do it, this is going to be a lot nicer for the code, I think.
Awesome. So I think you kind of already implied this, but in your example of changing the keyboard type, that would just not compile if you were running it on macOS. Is that correct?
Yes, and that's super frustrating.
Gotcha. Yeah.
It's almost better just to have no ops than to have things that don't compile. I get that it's for all the safety and stuff with Swift. If this were Objective-C land, all these things would probably be declared and they'd all be no ops.
Yeah.
Just because it makes for faster coding in that experience, but it makes for buggy code, especially when you expect something to work and it doesn't. So I don't know, maybe in Swift 6 we'll get a loose mode to the language where it doesn't have as many stringent checks, and it allows you to write quick and dirty code and then make it correct after the fact. I think that would be a great addition to the language. As a whole, I guess a lot of languages actually have this. They have a strict mode, right? Where the strict mode is essentially what Swift is all the time.
Right.
And I guess this would be the loosey-goosey mode, where things are just a little a little more loose. So feel free to steal this idea and take it to the Swift evolution proposals and make a pitch for it. Because I think that would be great for the language, especially for people learning the language, for it to be a little more, a little more
Forgiving.
Yeah, forgiving. Especially and maybe like push things towards the runtime level layer if they are like actually problems. But that would help in the long run for Swift as an education tool and for Swift as like a quick scripting tool. Currently, you really have to have Xcode follow along and correct you as you go to write any Swift at all. And that is a bit of a shame, I think.
So it would be like we're pulling a reverse TypeScript then, basically.
Exactly, yeah.
All right, cool.
Like, keep most of it, but like every now and then, whenever like Swift gets in the way, I guess, it can go ahead and just be a little more loose. It's just to have more no-ops, have more things that are just more implicit, or have implicit behavior, looser like rules when checking equality and all that. I think that would go a long way. Anything that the type system can catch for you and tell you to fix, it should just go ahead and do, basically. Sure. So next on our list is on the topic of like frustrations with Swift, automatic bridging between CGFloat and Double. So for those of you that don't know, CGFloat was added back in the olden days between the transition between 32-bit and 64-bit platforms. And CGFloat would be a floating type, a 32-bit floating point type on 32-bit platforms, and a 64-bit floating point type on 64-bit platforms, a double basically. Now Swift kind of has this carryover for both int and CGFloat as well. And for CGFloat specifically, it's a big pain, I would say, to go ahead and use this all over, especially since Apple's platforms kind of rely on CGFloat, but anytime you do math by default, it will make a double. So what they've added is a very specific bridging between only these two types. So there's no other like automatic casts within the language, but these two types are the exception. And basically, if you declare anything as, or have anything that is a double, the type system will work backwards to see, does this end up a CGFloat? And if it does, and it's not being used as a double anywhere else, it will just make it a CGFloat from that point forward. So you don't actually get any type conversions ever for that scenario. Or if it does get used as a double elsewhere, it will kind of do the transition between a double to a CGFloat at the last possible moment. And in most cases, this will be a no-op since it's going from a double, which is what a CGFloat is, to a double. But in some very specific situations, specifically watchOS and Watch, where some types are still 32-bit, I think there are 64-bit in general, but 32-bit pointers. I think that was like the specific instruction set, which is weird. But the older watches are still 32-bit. So this kind of is only useful in that one circumstance. And probably once those watches stop being supported, CGFloat will just be a double anyways. I don't know if this needed to kind of make it into language before they just turn CGFloat into a double, probably in the next year or so. But it is definitely a welcome addition.
Yeah, out of all of these, it's probably the least really impactful for most of us, but I am probably the most stoked about it because I can't remember if it was when I was doing a lot of Swift UI work or what, but just having to go back and forth between Double and CGFloat is such a pain, having to convert them manually. So this kind of implicit interchangeability of the two types is so nice. And I remember looking this up and seeing if it was in a proposal already, and it of course was. So I didn't quite know when it was going to be a part of, it was going to actually get accepted and kind of into the language and everything. But I'm very excited about this just for those, few instances where you're dealing with both of those types. And maybe it's just the code that I was writing was bad that I was dealing with both types, but it'll be nice that you can kind of go back and forth between them, just from like a developer, like in the moment coding standpoint, it'll be nice to get that automatic interchangeability.
Yeah, I have a feeling no one's going to notice when when this happens. It's
Yeah.
just going to happen, and everyone's going to quickly forget that they ever needed to go ahead and do the transfer before. Kind of like with the transition to Arc for memory management. It's like you quickly forget when you needed to put retain and release all over the place because the system is taking care of it for you at this point.
Right.
And then you also slowly start to forget the other rules where you need to call super and deallocate and stuff like that. And that has come to bite me specifically. Specifically while teaching lessons on manual reference counting. I'm like, why is none of this working? And that's because I forgot to call super and deallocate. Because I got so used to not calling super because that was now against the rules. So yeah. Lots of fun stuff when it comes to automatic conversions. Do you think we're going to get more automatic conversions between types?
Yeah, I don't know. Okay, so like, what would be some examples of that? Like,
Int to
string
double, for instance.
right? Okay, I was gonna say string and NSString basically already do that. Int to double would be cool. Yeah, like a lot of that with doing math between different number types would be really nice.
Mm-hmm. Or maybe to
Yeah.
specify within the language, like, hey, you can just go ahead and loosely convert between these two types freely. Like between strings and enums, for instance, that might be a common case where instead of specifying the enum, you can specify it as a string and it'll just dynamically get converted. I guess this is more for the loosey-goosey version of the language, right? That it will just accept more of these transgressions in a way.
Yeah, I mean, like I said, it's probably this double to CGFloat thing. It's probably not anything that's really going to impact anyone other than the developer themselves, but anything to kind of make the language more, how would I put it? Like, just have less friction to develop and just, you getting out of the flow state because you're like, oh crap, how do I, what's the best way to do this? I think that's cool as long as it's, there's no huge kind of impact performance-wise or whatever. But I'd assume that they're doing it, like you said, in a really cool way where sometimes it's just a no-op or sometimes it's at the very last second that they have to actually do the conversion and everything is, totally good.
Mm-hmm.
So next up, we've got Codable synthesis for enums and, with associated values. So that's pretty cool that it can just automatically synthesize or write the init from decoder or I was encode with encoder and init from decoder for Codable implementations. So that's, let's see. Yeah, that's automatic, right?
Yeah, so up until now, if you had an enum that has like a switch, oh my gosh, string as a backing type. If you had an enum with a string as a backing type or an int as a backing type, that would get Codable automatically. Anything with raw representable, that is Codable basically, would automatically convert. But if you had associated types, that would just throw its hands up in the air because it's like, well, what do you want me to do about this? So it's nice that this is now automatic. It might not be automatic in the way that your API needs it to be. So you might still need to do custom Codable. But if you are kind of just building out an API from scratch, this is a welcome addition. Basically, it turns the enum type into a dictionary, and then the dictionary has the associated type in there, keyed according to whatever the key, the parameter name is in your associated type. So you can actually have parameter names for associated types, and you can have multiple associated types. So all that goes into a dictionary, basically. And it's a dictionary that's keyed by the enum name, I believe.
The case.
The case, exactly.
Right.
So yeah, welcome addition.
Yeah, no, I think that's cool. Like you said, it's not going to be useful in every case, but just like what came to mind was, as another example of that is structs generating member-wise initializers automatically. Like sometimes that's not what you want, but sometimes it is, and it's sweet that you get it for free. So that's great.
And it's sweet when you forget about it when you're writing it within like a package, and you're like, why is this not coming out? Come on, Xcode. You quit Xcode, you restart your computer, you gently tap the side of the computer to persuade it, and it still never comes up. And then you finally remember, oh, I need to mark it as public. Actually, it seems like Xcode 13 does tell you, hey, this is not public. You should mark it as public, which is a super neat addition. Now, again, anything that the compiler can guess, like, hey, this is the obvious next step, it should do automatically in that loosey-goosey mode. Loosey-goosey mode for everything.
Yep.
So that's the outcome of this episode. And this is a perfect lead into the next one. And I guess the Codable synthesis stuff is probably more useful for Swift on the server, especially since you get full control over the conversions there. And on the topic of Swift on the server, there is now faster JSON serialization for Swift on the server. I guess they got a brand new implementation of the serializer that is used internally, which is neat.
Awesome. That's cool. Like as a part of Neo, or
no, it's just a part of the standard library.
Oh, cool. That's awesome. Another cool one I think is really awesome is you can now use the lazy keyword in local context. So, for example, in a function or something. So you could, I'm not going to say initialize because it's really not, but you could create a bunch of variables that, you can mark them as lazy, and within the function itself, if they're never used, they're just never initialized, and you're never needing to, do anything with them, which is pretty cool. So you can kind of selectively initialize things as they're needed, and, perhaps save a little processing memory, all that. So I think that's really cool. I'd never even thought of that, but it makes sense if you've got, quite a bit of branching logic, that might be really nice to not have to. You could maybe, now instead put all the variables at the top of the function, as opposed to kind of nesting them within the, different conditions or whatever, and kind of have everything front and center at the top, and then have all of the conditional logic, down below, kind of separate. So I think that's pretty cool.
I guess this, is it possible to use property wrappers in local context? I think so, right?
I like for variables.
Yeah, I think so. Yeah.
I think so. Yeah.
The reason why I bring it up is because in the pitch for property wrappers, there was like, hey, lazy as a system feature could go ahead and be implemented this way. And that would be like one way of going about like implementing your own lazy. And I guess maybe, I guess we can find out exactly if you wanted to. But perhaps lazy is now implemented as like a property wrapper internally. And now because of that, it can just be used as a keyword in any of those contexts. Now that might completely be false in terms of implementation. But it's nice to see, again, more homogeneity in the features of the language, especially where things can be used. I think the biggest obvious part where that kind of fell apart was with when SwiftUI came out, and you had what are those now called? They're not function builders, they're result builders.
Yes.
It needed like a completely different syntax. Where you can no longer use if statements, you can no longer declare variables, and everything just like this is a weird block of code that is not.
There's no commas in between lines or anything. Yeah.
So when that first came out and you couldn't do all those things, it felt like really substandard, and like nothing that you came to be used to with Swift could be used in that context. And then little by little, they added all the features back in. So this kind of feels the same, where they're kind of bringing features that can be used elsewhere. Like one of my favorites is to declare functions within functions. It's essentially closure at that point, but it's super convenient for handling like small subtasks and making the code really clear and easy to read, and obvious that this little function is really private to that bigger outer function, and it's never going to be used in any other context.
Continuing with this whole thing of extending functionality to just more parts of the language, we've got property wrappers can be added to function and closure parameters as well. So another place where we get property wrappers too.
Yeah, and property wrappers, if you don't like know exactly what they are, it's just a struct. And a struct is just like a box in terms of memory. Like whatever you put in it, it just encapsulates it and then throws some nice syntactic sugar on top of there where you can have methods and automatic triggers that happen whenever you change or retrieve values from it. So I think it's really nice that this kind of getting placed everywhere. You can currently do them on functions, right? You can do them on properties, which is why they're called property wrappers. I don't know if you can do them on types yet. Like, I don't think that's a thing. So maybe that's next on the list of like where to put these boxing APIs, where you can box a type and then it would be boxed in a different way, I guess. I guess that's how we abstract classes and structs, right? A class is just like a pointer. So maybe that's what a class ends up being, is just a class type wrapper on a struct that makes it a reference type.
Yeah, it could be.
Yeah. I guess optionals are essentially that, right?
They've got a cool example that I thought was just kind of a good, reason of having property wrappers in these parameters to a function. So Paul just wrote like a quick struct called clamped. So if you pass in some integer or something and you want to make sure it's within a specific range, he just does a simple call to the min value, calls min, then max, and then passes in the value and make sure it's between a lower and upper bound, just of a range. And if it's 0 to 100, but they pass in 200, then it would clamp it down to 100 to make it just fit with whatever the function itself is doing, that this property wrapped parameter is getting passed into. So I think that's cool.
I think it would be really nice if we can get, hopefully, I guess soon, more uses of all these property wrappers and stuff like that within the standard library or the foundation library. Because things like clamps, for instance, are really useful in many different scenarios. But like you either right now have to write it yourself, or you have to hope that SwiftUI comes with a version of it, for instance, if it's useful in SwiftUI. Like SwiftUI has a bunch of property wrappers, but they're all closed source. So they are only useful in the context where SwiftUI is available. So it'd be really nice if more and more of these convenience methods and functions and types make their way over to Foundation, where they can accelerate development for anything that uses Swift. I think that would be a nice addition to the language.
I wouldn't be surprised if kind of, in the future, now that these property wrappers are existing on not just properties, but now, parameters and everything, as it kind of grows within the language, we see some proposals for some of these things, like you're saying, just to be added.
Which brings us to the next thing that just got added to the language, which is static members on protocols. So basically what this allows is for protocols to have a static member associated with it, and that is basically like a class property or type property on the protocol itself, which means that anywhere you require like an object of type that protocol, you can go ahead and now type dot, and it will autocomplete with any types that have been extended on the protocol itself, which is super convenient for, once again, SwiftUI, the driver of most of these features. Like I found this out accidentally while I was using Xcode 13 during the beta period. I was like, oh, I need to like add a list style. So I'm like, okay, dot list style, open parentheses, dot. And then I had the options. I was like, cool, I'm going to go ahead and use this. And then that broke all of the CI because all of that was still based on Xcode 14. I'm like, why is this broken? I'm using the style that is available since like iOS 13. Like, this is nothing new. Apparently, it's because of this feature in Swift 5.5 that enables it. So the compiler actually needs to be updated, even if it will like run on older versions. This is one of those things that, like, I think marking, like bringing bindings through the for each view in SwiftUI is something that back deploys, which is super, super nice, which is not, like, we can't say that about everything that gets added every year. So anytime there is something that does back deploy, it basically means that your code gets compiled to work with the new way rather than relying on anything that Apple ships. So that is super neat.
Yeah, I really like this. Just another thing that felt a little bit off about SwiftUI, having to initialize the style every time. So again, just another kind of making less friction. That's awesome. I don't have anything else to add. I just think it's a great addition.
Yeah, a lot of these are like that, right? If they're so like minor, you're never gonna think about it again. But the moment it gets taken away, you're gonna be like, "What happened?"
Yes, exactly.
So also new is something called package collections. So these are bundles of other Swift Package Manager packages that all come from one source. So for instance, Apple has a package collection. It was the first one that lists out all of the packages that Apple has. And it's a great way of it's not really a language feature per se, but it's part of the ecosystem. And it enables Xcode, for instance, and the tooling to go ahead and suggest more packages by the authors that you trust, which is a great way of kind of getting more dependencies from trustworthy sources rather than just from the internet, which has never been a good idea. So yeah, a welcome addition.
Cool. So this is purely just for kind of finding more packages. It's not like you saying, "Hey, I'm going to import this one package," and it's actually going to import, 10 packages or something.
Yeah, it's basically Xcode will pre-suggest like, "Hey, here are packages from the Apple collection that you've subscribed to." So
Gotcha. Okay.
I think the Swift Package Index, which is an open source, I don't know if it's open source. It's a community run, I should say, website that basically lists out every Swift package that it knows about. I think they are going and also making package collections for individual authors. So if you as an author,
Gotcha.
basically your GitHub account ID, whether it's an organization or a personal, will go ahead and automatically get a package collection for that. So if you have many packages that you've published, you automatically get this for free, which is neat. And everyone can go ahead and check out all of them after they find out about one of them.
That's really cool.
So this leads into the big updates for Swift 5.5, and these are actually leading up to more changes that are coming in Swift 6 or Swift 5.6 as well, I guess. I don't know if we're jumping directly into Swift 6 after this one. But there's a lot on the roadmap for that big update to the language. And the first of those is async await. So Spencer, what is async await in a nutshell?
Oh yeah. Well, it's basically just a new API for concurrency. I think in general is probably like basically a replacement for maybe not all, but a lot of Grand Central Dispatch's kind of asynchronous code.
Yeah,
if I understand it right.
Yeah, so async await basically concentrates on just the closures. So it allows you to have continuation points. I think that's what they're called. Anytime you have a closure. So this linearizes your code such that it now happens in the order of execution. Is that correct? No. So instead of having closures where code that will happen later as a result of something you just started, and then it kind of, the next line of code that you have underneath that closure is something that happens before the code that occurred before it. So instead of having that tangled mess of code, you now have a very linear, non-indented sequence of events that will happen one after the other, just not immediately after each other. So anytime you have a closure, instead of indenting that closure, it now you'll mark that function with a wait, meaning you're going to wait for it to finish. And that closure will just be code that happens immediately afterwards. And the parameters for that closure will just be variables that will be returned from that function directly. This gets rid of a lot of messy APIs where, like, URL session, for instance, if you have a data task, you get a URL, a response, and an error. Is there ever a situation where you get a response and an error at one point? You don't know. The API makes no guarantees. You have to read the documentation and hope they didn't mess it up on the implementation side, because it's possible to get any combination of things once you make everything optional, right? So this basically cleans up a lot of those APIs and makes the code in general a lot easier to read.
Yeah, I'm really excited for this. I haven't tried this out myself in the Xcode betas or anything. However, I think this is going to be one huge change that, just like Swift, just like Swift UI, we're going to I'm sure it's going to become the norm here. Something that is exciting for me, I think, is also that this is, as far as I can tell, going to be implemented fairly soon as well in server-side Swift, like in Vapor, which I think there it will also clean up a bunch of things, because in Vapor you are very, just by way of using event loop futures, you end up kind of nesting closures over and over again. And if you've got something complex, you haven't broken it up into other functions, it can get very, very indented very quickly. So kind of making everything a bit more linear, doing the same thing, but in kind of a more readable way, is going to be really exciting. And I don't know if this is a part of, I might be getting ahead of myself, but one cool thing is there, as a part of this, there's like four or five kind of sections in here, but I think there are more proposals than that. They're making it sort of backwards compatible with Grand Central Dispatch's, dispatch async. So you being able to kind of adopt async await at your leisure. You don't have to kind of roll all of the Grand Central Dispatch code over to async await at once. So that's, nice to kind of not, everyone isn't freaking out and being like, oh crap, we have to overhaul the code base. It's kind of, do it at your own leisure. And I don't think Grand Central Dispatch is like dispatch queues are, they're not deprecated or anything. So at this point,
it's definitely a different library. So GCD is a separate library from Swift, and it actually does need to be compiled separately. I believe it's required by Foundation, but it's not part of the Swift standard library set of features when you compile Swift from scratch. So that is completely separate, which is nice. And as you said, like async await comes with a bunch of helper methods to kind of bridge that gap between Grand Central Dispatch and the new Swift concurrency stuff that we'll talk about in a bit. But since you brought up Vapor and like Swift Neo, for instance, it takes a real skill to be able to manage those callbacks properly, and to have them be linear and not like a cascading pyramid of of code. And it's actually pretty hard once you get a few levels deep to make sure that you have all the data that you need. It's like, the variable I needed was like used 3 closures ago. It's not like you can just use it. You need to remember to pass it down the chain. And async await gets rid of all of that complexity instantly because you just declare a variable. And you don't need that variable yet. That's fine. It can just hang out where it is. And you can take your time to get to the point where you want to actually go ahead and use it. It will be there for you. Like the compiler will take care of setting up the stack and everything for that. So this is like a super welcome addition, especially for all that. I believe async await is merged into Neo. I may be wrong there, but I believe it is. And Vapor does have a branch with it like enabled. So you can go ahead and play around with that there. They're still bringing changes in to make sure that the API surface is like nice to use for Vapor. So if you do go ahead and start using it, like contribute back and give your opinion, so that way others can know how to use it, because so far everyone is kind of settled into let's write crazy completion handler
Yeah.
maps that go from one to the other, and they gotten good at that, so there's no reason to kind of switch and start using the async await stuff. So if you do want to go ahead and play around with it, do go ahead and give your feedback. I'm sure it'll be much appreciated.
Yeah, for sure.
So this leads into a slightly more complex use of async await, and that is async sequences. So async sequences are a way of dealing with data that you don't all have yet. So for instance, a good example of this is if you are loading stuff from a server, lines of text, for instance, and you want to process each line of text as it comes in, you don't necessarily want to wait for all the lines of text to come. Async sequences are perfect for this because you can say for line in await lines, or something like that. I don't have anything in front of me, so I'm ad-libbing it. But you can go ahead and have a for loop in that structure, for instance, and that will go ahead and just, as soon as a line comes in, it will be funneled through the API, and then your for loop will run one iteration, and then it'll just wait for the next one at that point. So you still have very linear code, but it will go ahead and wait for more information to come as it comes, and if there's an error, it'll just stop and throw that error for you at that point in time. So it very much is like what we were talking about previously of how certain features of Swift kind of need to propagate to everywhere else, so that way they're usable everywhere else. Well, await is one such keyword that is usable in one context, and now it's going to be usable in more and more as people kind of run into the limits of the system. More of these will surface. So this one was thankfully one that got brought in early enough, like before even the beta period started. So it was like well drawn out. But I'm sure there are going to be more scenarios where people are going to want certain use cases for async await that is just not going to be possible yet. So we'll see.
Okay, so I don't 100% understand this one. So it's not quite like a dispatch group, right? Where it's waiting until, like, if you had this in a for loop, it wouldn't, wait until the for loop is finished to run something or inside of I forget what it's called, but like the completion of the dispatch group. It seems more like almost a combine, and now I'm forgetting the observer and combine, where it's
it's a stream of data.
Yeah.
So you are going to, the data is not all there yet. It could be, like, there's nothing preventing it from doing it, but maybe it needs to be processed. Maybe there's like a chain of events that needs to happen all in parallel on each item. But your code, your for loop, is going to be a serial implementation. Basically, it's going to just work on one at a time as the data gets transformed and is ready to be processed at that point in time. Okay. So I'm not sure how to do that transformation part. There's some built-in pieces, like dot lines will give you an async sequence from a sequence of bytes, useful from the network, for instance. But there isn't much more that's like built in. Again, with the built-in functionality, that would be nice to have. Like, for instance, for whenever you're dealing with unserialized data, there's many different very common patterns. Like, you decode an integer, and then you use that integer to decode the next X bytes. Or you decode until you hit a certain byte sequence. Right. A lot of those things are super common, and it would be nice to see API come up that kind of implements a lot of these things, like from that, so that way they're ready to be used. But until then, what this for loop is going to do is just going to go through one entry, basically wait on the next entry to be ready, and within that completion handler, go to the next entry and so forth until there's no more entries, and then it'll continue to the code that's after the for loop. So it's not doing anything in a concurrent way. It's just allowing your code to be non-concurrent but concurrent friendly, if that makes any sense.
Yeah, totally.
And then I'll link to it in the show notes, but David Smith, who works on a lot of these low-level features in the Swift language, he went and tweeted basically a conversion from the new async await syntax over to what it would have been with closures, so that way you can get an idea of how this transformation is taking place. And that's an excellent way of realizing how to go ahead and do this with promises and futures with Swift Neo. And it's a pain to kind of wrap your head in this kind of different mindset, where this one is going to immediately feel very natural and easy to follow.
Awesome.
And that, again, leads into structured concurrency, which is the next kind of big flagpole for the language. And this is basically allowing Swift as a language and as a compiler to make sure that you don't mess up when it comes to dealing with concurrent tasks. So this is the replacement for GCD, essentially. It gives Swift its own thread pool to go ahead and process things. It will go ahead and be very intelligent in how it skips between one execution context and another. Basically, if I'm remembering this correctly from WWDC, it will go ahead and take a snapshot of the stack before awaiting, basically, and it will go ahead and save that in the heap. So that way, the stack does not grow as Swift needs to switch to these different execution contexts. And once it does switch to some other work that needs to be done, it will go ahead and move its stack from the heap back onto the stack, so that way you can go ahead and process it. So if none of that makes any sense to you, I most definitely did a poor job explaining it, and there's a great WWDC talk on this that I recommend you all to watch. But this basically introduces a new type called a task. And a task takes a completion handler, much like dispatch queue can take an asynchronous block.
So I think this is kind of a part of it. I think it's a different proposal, but the continuations for interfacing async tasks with synchronous code. And one thing that they bring up is you can have these check continuations to, for example, make sure that you call resume on a data task only once. Am I correct in assuming those are kind of somewhat connected?
Yeah, so it basically makes sure that you as a developer don't mess up either by forgetting to write a line or by copy pasting some code and then it calling us the completion handler twice. It prevents all those sorts of situations because it takes away that ability from you, and it gives you a brand new superpower of having the compiler type check everything all the time. Which I guess this one would not be a candidate for loosey-goosey mode.
No.
That you definitely want to be there. Mostly because it makes the code easier to reason with.
Cool. That's awesome.
And a big part of this is going to be a new type that's coming to Swift language. And it's a new reference type of all things, an actor. So have you heard of actors before they made their debut in Swift?
No.
Me neither.
No, I basically just live in Swiftland anyway, and Objective-C kind of by extension. But
so same. I've never heard of actors. I don't understand like the naming of how we got to actors. And soon we'll talk about sendable, and that's an equally like how did we pick these names?
Yeah.
But apparently there is a prior art for having these terms, and that's why we have these along with decks. That's how they come about. So actors are a new type. It's a reference type, and you can go ahead and use them to have a thread safe data, basically. That if you think about it, it's kind of like implementing a class with an internal dispatch queue that kind of serializes everything that comes in terms of access and writing. But it does it in a more interesting way where you don't have to keep track of this queue. It's just going to never put a read or a write that accesses the same object on two different threads at the same time. Doesn't mean it won't jump from thread to thread. It just won't ever happen at the same time. And this is a guarantee that's made by the language, which is really neat.
So it's basically just a lock, more or less.
Yeah, it's a lock on all the properties, but intelligently done where if you don't need to grab a lock on like static data, for instance, it won't make one. And anytime that you do need a lock, it will guarantee that you acknowledge that, and it will turn anything that may take a while as a result of that lock into a completion handler, which is a continuation point for the async await system.
Cool. That's really cool. I'm interested to see how much this is adopted. I, can't really think of a great use case off the top of my head, but as soon as, you're dealing with anything concurrent, I'm sure there are plenty of situations for this.
Mm-hmm. And they basically encourage you to use it liberally. So if you have like a chatting app and you have multiple like message threads, just go ahead and use an actor for each thread. It will go ahead and keep track of all that. So I guess anytime you think you might need some concurrency, instead of using a class, use an actor and see how far it takes you. And then you also get, which is I think even neater, global actors, which I think there's only one of, the main actor. And this allows the system to basically make sure that you don't forget to call dispatch_queue.main for anything for UI related. And it will enforce this. Basically, anytime you use structured concurrency anywhere and you happen to jump back to the main queue, it will go ahead and turn that into a proper await, basically, and make sure that you don't do that incorrectly, which is really, really neat. And I don't know if it requires you to mark stuff with @main actor little by little, or if it kind of knows automatically. We'll see. Excuse me. We'll see as more people use it. But it's definitely any tool that basically prevents bugs from ever surfacing up. I think is definitely a big welcome addition.
Yeah, especially having it be just a property wrapper like @main actor, super easy to do. It's at the start of the function. You can either know, oh yeah, this is something that's going to be, need to be run on the main thread, or do it afterwards, being like, oh crap, I am, touching some UI element, throw it up there after you write the function, and you're golden. I think that's all you need to do is just put that @main actor. So that's nice and easy.
Yeah, and if you access anything that is not an actor or is not marked with @main actor, or could be like problematic because it's a reference type and you weren't especially like cognizant of that, there's a new protocol, and that is sendable. And sendable basically marks any time you have a thread safe type. That's basically it. So if something is sendable, then you can use it as much as you want within the new structured concurrency stuff. If something is not sendable, the compiler will yell at you anytime you try to attempt to use something that is not going to be safe. So a
lot of things will be sendable, basically.
Yep, and to mark something as sendable, you have to make it thread safe, basically. So It's not like you can just mark something and forget it. It actively is keeping an eye on it, so that if you make any changes after the fact and you're not necessarily aware with how everything fits together, it's going to make sure that everything continues to work, which I think is the best part of Swift.
Yes.
Like you can't accidentally break something from like negligence. You can, but you can't introduce like one of hundreds of other bugs that everyone has definitely introduced in their own experience, even if you're not aware of it. So Swift catches a lot of those issues, and that is super nice.
Yeah, I think with a lot of these things, we're kind of going on the opposite way of loosey-goosey. We're going more and more strict, but it really is kind of for our own benefit.
As much as we
making
hate
sure
it.
that as much as we hate it in the moment, it's, we're writing safer code because of it, and having things like this main actor or at sendable, it's a small price to pay, I think, for the, I'm sure, copious amount of bugs that we could cause ourselves if these things and even type safety weren't there. I have never written JavaScript, but I do not know how people can feel safe writing JavaScript, and that just seems like a lot of mental overhead to make sure that you're using the correct type or whatever in the right place. So I for one welcome our safety overlords, and I think that's kind of it as far as the changes go. Am I wrong?
Yeah, I think that's all of them for Swift 5.5. So check back with us next week as Xcode 13.1 comes and we have Swift 5.6.1. No, but I do want to encourage everyone to keep an eye on the forums, keep an eye on the Swift proposals, because it really is fascinating watching this come about. Because a lot of these proposals don't start this way. They start either very differently, or they have a whole bunch of tasks that either get merged in or things change as a result of it. So I'm really happy that Apple is kind of doing this out in the open, and they're encouraging the people that are working on it full time at Apple to talk about it in the open. Because it's definitely been a great learning experience for myself in terms of API design and going through and learning about all these sorts of things like actors. I would have never ever known about actors in my whole life because I didn't go take computer science classes, and I'm sure that's something that is brought up from year one. You're going to talk about all these different ideas that have come about over the years and decades of computer science. And a lot of us have just jumped into app development. We never really seen all of that. So this is a good opportunity to see a lot of these concepts be brought up, see how things are fixed, see how things are made faster. For instance, there's a few proposals that just landed. One for, I think, bringing all the Unicode specification into Swift instead of being a separate kind of import from the C side, which will make embedded Swift a lot more feasible because you don't have to include all of string parsing that exists for your 2 megabyte microcontroller that doesn't have the space for that. So that's one such example. So that just landed as a proposal. And another one that just landed is string parsing, which basically, if you've ever used regular expressions, you've learned to hate them because they are inscrutable and horrendous to look at, especially as they get more and more complex. So that is coming to Swift as a proper language feature. Yay.
That's
but
awesome.
as an addition to that, there's a brand new kind of API that's also coming called Patterns. And this is basically Swift UI for strings, if I can explain that correctly. So basically, you can go ahead and describe your regular expression using full words and nice indentations and explanations for what's happening at every step. Add modifiers hey, do you want one of these characters? Do you want between 2 or 3? Do you want 5, 6, or 7? Whatever you want, you can describe it as basically a result builder, and add captures to that, and then you can go ahead and parse strings using this new and improved syntax over regular expressions. So if you go and read the comments for this proposal, for instance, you can go ahead and see that a lot of people are happy that regular expressions exist. A lot of people hate regular expressions, but everyone is more or less agreeing that this new pattern API is way better, and it's good that regular expressions are kind of there, but it's also great that we can go ahead and move further from that. So if you have regular expressions that you need to use, you can use them, but you aren't necessarily encouraged to write new regular expressions because there's something better. I almost wish that if you were to debug a regular expression, it might print out pattern code instead,
That'd be cool.
which would be great for here's a regular expression. I'm going to print this in the debugger and I'm going to copy that code and paste
Throw it
into
in.
mine, and then you can make tweaks to it because now you understand what's going on.
Right.
So we'll
That's
leave a
cool.
link to that one in the show notes as well.
Yeah, for sure. I've never really done a bunch of string parsing, and I've heard from others that know other languages that Swift's string parsing is, I think, somewhat lacking. So that's exciting to hear. Good stuff. I
Definitely.
mean, that's the thing. I'm sure that they've got so many engineers at Apple working on Swift and trying to improve it and everything. But by them making it open source, you have so many more people that are using it on the daily for different use cases and who all, have probably similarly good ideas for how to improve the language. If, they're running into an issue, it's likely that someone else will. So I agree that it's very cool that Apple has, I think for the most part open sourced it. Like we talked about, a lot of Swift UI's property wrappers and stuff are closed source and stuff, but I think that's more the exception than the rule. So
Yeah, people were definitely mad when SwiftUI dropped, and I was like,
I remember
"Oh, there's
that.
all this extra stuff in the language that no one asked for our opinion on." And like, yeah, it's Apple's thing. They're gonna go
Yeah.
ahead and add stuff to it whenever they want, based on what they need for the language to be able to do.
Yeah.
Like, we can't do anything about that, but you can influence how like function builders get turned
Yeah.
into result builders. You can influence that whole process. If you have good ideas. If you have bad ideas, you can't influence anything. But
Yeah.
you can definitely have a say, and have your opinion be heard, which is really nice. So, for instance, with Async Await, that was going to be just brand new, only to like modern versions of iOS and macOS, rather than backported. But because a bunch of people said, "Hey, like no one's going to use this for years if you don't
Yeah.
backport it,"
Yep.
then Apple kind of prioritized that, and made it happen from an engineering point of view. It's non-trivial to backport core features to the runtime, all the way, because a lot of Swift editions are not runtime features, they are compiler features. But this one really is one that requires a lot of runtime support, and you can't just staple on runtime support for back versions of the language. So they are slowly making progress there. It's not set in stone yet that it will happen, but there is a chance, and there has been progress that has been merged in, and there continues to be, for getting like async await available to older versions of iOS. So we have to either be patient or contribute to it as well, if you know
Yeah.
what you're doing.
Yeah. Just be a part of this discussion where you can. That's cool. I don't think I would ever submit a proposal. I don't think I, I don't know. I've never had an idea. That's just way beyond me. But I think it's cool that it's on GitHub and you can go on there and comment. And if you have any input, maybe it's a proposal that's already there, you can still be a part of the discussion on where it goes. So that's cool.
And even if like your comment has already been said 3 times, it helps to say it a 4th time, because that is basically a vote for that camp, basically. So don't be shy, even if it's saying I agree, like doing it in this way, and you have nothing else to add. That's totally fine. Don't attack people. Like, everyone is kind of
Yeah, be civil for
working
sure.
on best intentions, for many of these things. So like, you can't make anything happen, but you can influence it, for like the direction that you do want it to go in. And if you have a good argument to be made, everyone's going to listen, whether they necessarily agree with your initial point or not.
Yeah.
So this week's episode of Code Completion is once again brought to you by Super Easy Timer. Super Easy Timer is a quick and easy to use timer app for your Mac. It's completely text-based, so you can type in English what you want, 20 minutes or 5 p.m., hit enter, and instantly start that timer. The timer understands English text to create, update, and start a new timer. You can quickly change an active countdown, even while it's still counting down. There are simple keyboard shortcuts to reset or pause, no menus, no sliders, just use English to control your timer. We want to thank Super Easy Timer for sponsoring our show. Search for Super Easy Timer on the Mac App Store today to give it a try. So now that we've completed our topics, it's time for Complete the Code, where we quiz our listeners on your knowledge of Swift, Apple, and all things development. Spencer?
Yes. So last week we had an async await question for you all. And now that we've talked about it, we have a winner. So that's exciting. The question is, how would you transform the networking code shown to use the new async await pattern? And Edgar's, who wrote it all out, print preparing in a string, then start a new Swift 5.5 task block, like we talked about briefly, where we declare a tuple with underscore for the first parameter and let response for the second. Then set that tuple to be equal to try await URL session .shared .data for HTTP request, which will put the current execution context on hold until it gets a response or it throws an error. Following up with a print that we've received the response. After the task block, print sent request, which will actually get called before the task completes. And that works just awesome. This week we have an explorative UI kit question for you. So if you're listening to the podcast, you can check the podcast or the show notes to follow along as always. How can you use UI view controllers update view constraints to quickly swap between very different view layouts?
So thank you, Spencer. So if you can complete the code, tweet your answers to us with hashtag CompleteTheCode, all one word. The first to get it right will get a shout out on the following week's show. So as always, I want to personally thank everyone for listening in this week. Please be sure to follow us on Twitter at CodeCompletion so you can know when new episodes get released, and feel free to tweet at us if there's ever a topic you want for us to dig into. Most importantly, as a small podcast, please be sure to share this with your friends and family who are also interested in any part of the process of app development. It's really your support that enables us to continue doing this, and we hope to grow a healthy community around everything we discuss. Once again, I want to give my thanks to Spencer, who is at Spencer C. Curtis, that's SpencerCurtis on Twitter, for joining me this week. My name, once again, is Dimitri. You can find me at Dimitri Buñol, that's DimitriBouniol, and we'll see you all next week.
Bye. For everyone that is not in our Slack, which is the entire world except for 6 people, Dimitri, as he was preparing today's episode, and he was getting that IndieAppSpotlight ready for the SMS, text filtering and everything, he got the smart filter. He got a fake Wells Fargo suspicious activity text. So that was very timely and relevant. I thought that was pretty funny.
So do you know what I did? I downloaded Smart Filter and I tipped away because I don't want those anymore. I'm so sick of spam lately. So talk about relevant.
Yeah. I haven't got a ton of text ones, but I get a ton of just spam email. I mean, it's ridiculous. Just on the daily, how many... And, they all go into your spam folder, and it's like, you won X amount of Bitcoin, or...
my
whatever.
Spam filter has given up. I'm at 63,318 emails in my inbox.
You're more than halfway there, man.
I know. I need to get to 100K just to see if the little red bubble will keep up with me. But I read it every morning, but I can't go through and mark a spam, archive, mark a spam. It just takes too long. There's hundreds a day. I'm never going to get through it. So I just gotten to the point where I will read through it. When I need to read through it again, I'll go down to the point where I see, I've read an email. Let me continue from there. That's basically all I can do at this point to keep up with it. It's really sad. Oh no, this is my cable. Please don't eat my cable. Ow. Cat eating my headphone cable. I
think we talked about, you mentioned this before, but you, at the very least in the past, probably earlier, first 3 or 4 years of iOS, mm-hmm. you have experienced jailbreaking a device, right?
Yes, I've also experienced being unable to update an app because the computer that was on the local network had jailbreak stuff on it, and that prevented the app from activating, the iPhone from activating a normal, through a normal process, and sweating bullets, nothing is working.
Wow, I didn't know that.
So yeah.
That's crazy.
Because that's how old jailbreaks would work. You had to spoof the activation server that Apple was connected to.
Interesting. So I remember doing it, I think it was probably with my second generation iPod Touch, before I had an iPhone. And, I remember there was one tweak you could download that would let you just modify like the bubbles, like the number, whatever, notification bubbles and stuff. And you could put whatever in there. I don't know if I ever tried like to make a super long bubble to see how large the number could get. But well, you could probably just write an app to see just for fun.
Yeah, just
set how large you could do it. But
yeah, I think there is a limit at 100K, like it's 999.
Is it
99, 999
plus or whatever?
Yeah. Well, if there's room for a plus, you can put the 1.
Yeah, that's true. Good point.
That's one thing I always hate whenever there's like truncated text. Is like if there's room for the ... you had room for the one character that you hid with the ... It's like,
yeah, good point.
So it's like those little things in UI design where you have like a show more button to show one line. It's like,
yeah, come on,
you could have checked that. Just like checking plurals and putting S's, things like that. Like, yes, it takes extra work, but it's worth it in the end.
It's literally an if statement. Yeah.
People appreciate it, I should say.
I can't remember what app I was looking at the other day, but it was like a very well-known app, and it didn't do that. It just would always say, it would have a plural, and it would never check if it was one. It was like, come on, guys.
The worst laziness is when they put the S in parentheses. It's like,
yes,
they couldn't be bothered
to write an if-else statement. Come on, man. Or ternary operator or something. Yeah.
I mean, UIKit has like such nice stuff for like string dicts now, where you can go ahead and localize per language. Oh, if it's 0, if it's 1, if it's 2, if it's many. Like for every different language, you can put all the different rules, and it'll just take care of it. It's super nice, but it's kind of complicated to set up, and the tooling needs better support. But alas,
indeed, localization's crazy. I mean, we do that at work and stuff, and it's just like lots of NS localized strings everywhere.
Mm-hmm. Yeah, code no longer looks like the app anymore, which is unfortunate. But yeah, it happens. At a certain point, the project grows to a point where you need to support multiple languages properly. And if you don't, then you don't get those customers.
Cool. Yeah, for sure.
I don't know if I'd recommend it for indie projects, though. Like, unless you natively speak those languages, it's probably not going to be worth it for you to like localize out of the gate unless you already have a popular product. So, unfortunately, do keep that in mind, like when you are writing apps.
Yeah, you could do something like I can't remember if it's with Hungry or Not Pho, but you guys have like the localization files just on a GitHub repo, isn't that right?
Yeah, and not like, a single person has shown interest in suggesting that things should be different here or there. So, again, I don't know if it's worth it for that.
If it got popular enough, someone would surely contribute to, German or whatever language you don't have. So I think that's a kind of a nice middle ground there, as maybe, like you said, setting it up to get to that point is maybe more work than it's worth, though. I don't know. I've never had to kind of set up that architecture for the localization itself.
Yeah. So if you want to see localizations happen for NAFA, go download NAFA and support it. And then go and help make it popular. That way someone will feel the need to translate an entire cookbook's worth of text into another language.
Yeah.
But at the very least, no one can complain.